All right, I think I'm set up. Get that one up. Let's reference that. All right, today, again, the work really is not difficult. It's really formula work, but we're going to do it the hard way first, and then you can do yours just using the formula. But let's understand where the formula comes from, and we're going to talk about distance today. So what I got on here is I got a coordinate plane, and I got your Pythagorean theorem from yesterday. And if you recall, Pythagorean theorem from yesterday states that a right triangle, the best right triangle I can draw, right? You have A here, B here, and your hypotenuse, or the longest side, the side opposite that right angle, is C. So our distance problems are going to be asking questions like, what's the distance between 2 points? So we need 2 points. I'm just going to pick 2 random points here. I'm going to pick this point here, and I don't know, let's pick this point here. Now we got 2 random points. They're in different quadrants, which doesn't really matter, but I want to know the distance between them. So I want to know the distance of this line right here. I want to know what that distance is. And we can use our Pythagorean theorem to solve that, actually. If you notice, we have a triangle here. It's a bit hidden, but if you look closely, if you follow our slope, our rise over run, we have a line here, and we have a line here. And this makes a right triangle. And the distance opposite that right triangle is our hypotenuse. So this is our value for C. So the question is, what is the distance between this point and this point then? Or what is the distance between this point and this point then? Can I get my legs out of that? And due to the fact that this triangle is now has vertical and horizontal segments, you can just count the segments to get those lengths. So from this point down here, you have a change of 1, 2, 3. So this length is 3. And from here to here, you have a change of 1, 2, 3, 4, 5. Of 5. So now I do have my A and B value. And to find my distance between these 2 points, I can use my Pythagorean theorem with A and B and solve for C. So let's go ahead and do that. Let's say that A here equals 3 and B here equals the 5 and C is our unknown length. That's what we want to find out. So let's go ahead and plug those into our formula. That would be 3 squared plus 5 squared equals C squared. And we can solve for 3 squared and 5 squared. 3 squared is 9. 3 times 3 is 9. And 5 squared, 5 times 5 is 25. And that equals C squared. You can also add these. 25 plus 9 gives you 34 equals C squared. And then you can actually solve for C by taking the square root of both sides. So we'll take the square root of this side, and we'll take the square root of that side. So I know that the square root of 34 equals C. And then we're going to see if we can reduce this radical in any way. So again, you're thinking about what kind of prime factors go into 34. 34. So well, we know 4 is not going to work. We know 9 is not going to work. 16 is not going to work. 25 is not going to work. So yeah, we're not getting any. So that is the smallest it can get. So this is reduced. So your distance here is whatever the square root of 34 is. You can use your calculator to give an approximate value of that. So you can do the square root of 34 is approximately 5.83. So that's what this distance here is. And it does look kind of like 5.83. It looks closer to like about 6 blocks going there. You got 5 over the top and inside a diagonal, so you know it's going to be more than 5. But that's one way to find the distance between them. However, this requires you to plot points every time you want to find the distance between those 2 points. What if I just gave you the points? So we're going to go ahead and define each of these points. We'll call this point A, and we'll call this point B. Note those are capitals. Do not get them confused with our lowercase a and b values here. You name points by capital letters. So let's say over here we have the distance between point A and B, and A is, well, this is your origin. A is over 1, 2, 3, and 1, 2, 3, 4, 5, 6. A is at 3, 6, and B is at 1, 2, 1, 2, 3, negative 2, 3. So what if we just had our points? How do you figure out your distance formula? Well, you should note that it's kind of similar to slope here, right? You're going to go rise and run, and you want the difference. How much does it go up or down? So I'm going to take the difference between my my x values and the difference between my y values. And those are going to be my a's and b's. So here we're going to look at it as, we'll call this x1, and this y1, we'll call this x2, and this y2, and we'll find our difference in the y's. So y1 minus y2 is going to give us y1 minus y2 is what, 6 minus 3, and then you have x1 minus x2 would be, x1 is 3 minus, and then that is a negative 2, so watch your sign there. This is going to equal 3, and this is going to equal 5. And you'll note there's your 3 and there's your 5. So just keeping that in mind, we now have our A and B values. The nice part about this also is that we really don't care about negatives, because when we plug into our Pythagorean theorem, it gets squared anyways. So it's going to get rid of that negative and make it positive when you square it anyway. So we really don't care about negatives here. We really don't care about which one we do first either. I guess I did y's first just because I related it to slope, because slope you also found the change in y values and the change in x values. So it is similar in that sense. But this will give you your a's and b's. And then you can plug it into your Pythagorean theorem like we just did here, and you'll get the same work. What's going to happen though is we're going to combine both of these things into one simple formula. Well, it's not that simple. Into one formula that you can use to solve this right from the get-go, and we'll just plug right into that formula from now on. And if you look at the notes from yesterday, I gave you the formula in the slideshow. So over here, you'll note that we're taking the differences of y's and x's, right? And then we're going to square those, and it's going to equal c squared. So what I'm going to do is I'm going to say, hey, instead of saying a squared, I'm going to say x1 minus y1 squared. Because again, a was that, well, I guess it doesn't matter which one you call what. We'll call this y. y1 minus y2, sorry. Minus y2 squared. Do it. Because you'll note y1 minus y2 was that 3, and over here we're squaring that 3, and a was 3. So we're going to go ahead and write it like that. This will fit any case for any y's. Then we have this plus sign in our Pythagorean theorem, so we're going to add another value, and here we have our x values, so x1 minus x2, and that also gets squared, and that's like that 5 squared. These are interchangeable. You could have did x's first or y second, it doesn't matter. And all of this is going to equal c squared. So that's all well and good. However, our answer here is going to be c squared. It's not going to be the distance. So this really isn't solving for distance. This is just solving for c squared. So what we're going to do then is just take the square root of both sides of this. So if we take the square root of that, they will cancel, but then you got to also do it to this side here, and it's taking it all of those. So your distance formula is going to be distance equals the square root of, and again, these are interchangeable. I'm going to write the x's first this time, but x1 minus x2 squared plus y1 minus y2 squared. And this here is your distance formula. That's where it comes from. It is pretty much the Pythagorean theorem, only when we use points, we're going to use x and y coordinates for it, as opposed to a's and b's. So let's go ahead and use this formula to now solve this problem. Even though we solved it twice already, we should be getting this as our answer. But let's plug our points into this and see how it works out. I'm going to move it here. Let's move our formula down here. Let's do it over here. So over here we have, we're still using these 2 points. We're still going to call x1, y1, x2, y2. Might as well. So you're going to get d, and then you're just going to plug in chug. So we're going to plug into our formula. We got a square root symbol, we got a parenthesis, we got an x1, but I know x1 is 3, so I'm going to go ahead and write 3. Then we got a minus sign, and x2, and I know x2 is negative 2. I am going to put that in parentheses. But you can instead clean up the signs right away if you wanted. But I'm just showing you how it gets plugged right in. And that all gets squared, so so the whole thing is also in parentheses, and that's getting squared. Then we have a plus sign coming from here, another parenthesis, and y1 minus y2. So y1 is 6, minus y2 is 3. And that whole quantity is also getting squared. And then you take the square root of that, and it should equal your distance formula, or your distance. So then we can go ahead and clean things up in here. Again, clean up the signs here. This is going to become distance equals the square root of, what is that, 3 plus 2 squared plus 6 minus 3 squared. 3 plus 2 is 5. 5 squared is 25 plus 3 minus 6 minus 3 gives you 3. 3 squared is 9. And then you take the square root of whatever that is. And that's going to equal your distance formula. So 9, this is going to be the square root of 34 equals your distance. And that's what we were getting up here. So it is the same thing. But you're more than welcome to use the formula now. Just note that it comes from making triangles on your coordinate plane with points. Let's get one more example using the formula here. Once I find a good one, maybe one that will actually give us a perfect square. I don't know. Yeah, this one doesn't, but let's get different points here. We don't need any of this anymore, with the exception of our distance formula. So remember, distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. So remember your formula, that's what we're plugging into. And we need we need 2 points. So we're going to have our first point at 1, negative 5, and our second point at 3, negative 2. It does not matter which one you call your first point and which one you call your second point. I'm just doing it in order, so I'm going to call this x1, I'm going to call this y1, I'm going to call this x2, and I'm going to call this y2. And then I'm going to go ahead and plug it in. So here we get distance equals the square root of x1 is 1 minus x2 is negative 5. I'm going to go ahead, again, you can do it like that, or you can clean up your sign right away and make that plus. That all gets squared, plus y1 is negative 5. So watch that, and y2 is negative 2. So minus negative 2. Again, I'm putting that in parentheses to keep your signs up. I'm going to clean up the signs now, though. You'll note that these two become plus, these two also become plus, so you're going to get distance equals the square root of 1 plus 5 squared plus negative 5 plus 2 squared. Here, solve your parentheses and square it. You can probably do it in one step, but we'll do 6 squared plus. And then watch your signs here. We have a negative 5 plus a positive, or negative 5 plus a positive 2 now. So this is going to become a negative 3. Watch it because it's the negative 3 that's going to be squared here. So do not combine that with this plus sign yet because we need to square it first. So don't fix your signs here to just be minus. We need to square this first. And watch when we square it, it's going to make this a positive number. So we're actually going to leave the positive sign. So 6 squared becomes, is it 6 times 6 is 36. Plus, and then negative 3 squared is going to be positive 9. Remember, when you take that negative with it, you're doing negative 3 times negative 3, which gives you a positive 9. So over here is going to be 9. And don't forget our radical. We are square rooting all of these. And we are just carrying down our distance. So 36 plus 9 is going to give you 45. So d equals the square root of 45. Can we reduce that? We should be able to take out something. You can take out 9. That's right, yeah. You can take out 9. So distance equals the square root of 9 times the square root of 5. So that's going to be distance equals 3 square roots of 5. Yep, you can't take it any more than that. So that would be your answer. Any questions so far? Wasn't x2 equal to 3? Was x2 3? Did I do that wrong? x2 is 3. I did that wrong. You're right. Sorry about that. Thanks, Gabby. Let's redo that. But yeah, this is me just copying things wrong. My biggest mistake ever. So d equals the square root of x1, which is 1, x2, which is 3. I went with y1 on that. So minus 3 squared plus your y's, which is negative 5 minus negative 2 squared. So this side's not going to change, but that side will. Yeah. So 1 minus 3 is going to give you... Again, we're not really worried about negatives here because we are squaring them anyway. So I guess we're going to close that parenthesis. And it's getting rid of that negative. So you could technically say, hey, this is going to be like your 2. But 1 minus 3 is going to give you negative 2 squared. But when I square that, it's just going to be positive anyways. And then over here, again, clean up your signs. That becomes a plus. So negative 5 plus 2 gives you that negative 3, which again, it's going to get squared out anyways to be positive. So this is just going to be 4 plus 9. And that is the distance is the square root of 13. And you can't do anything about that. So sorry about that, but thank you, Katie and Gabby, for pointing that out. Appreciate that. So make sure you identify your variables correctly and actually substitute incorrectly, unlike Mr. Brandt did there. But distance formula really is not that bad. The other thing it wants you to do in this chapter is find midpoints. So we'll go over the midpoint formula, which I'm just going to give you because it just kind of makes sense anyways. But So let's say we had let's pick another problem here. I can find 2 points here. We'll pick -1, 5, and 4 and -3. So we just want to know how to find the distance. Maybe we want to find the midpoint. The midpoint is the location that divides the distance in half. That divides the distance in half here. So we do have a formula for that, and it's kind of a strange looking formula because it's actually 2 formulas in one. You got to do the x coordinate and then you got to do the y coordinate as well, and you get that, but it's actually pretty straightforward. So it is set up to look like an ordered pair. So this one here would be your x coordinate, this one here would be your y coordinate, and to get your x coordinate you just add your 2 x values and divide it in half, and that would be halfway through it. So x1 plus x2, and then you're going to take that and divide it by 2, cut it in half, or multiply it by half, however you want to do it. And over here you're going to have y1 plus y2, and you're going to take that in half. Order does matter here because you're not squaring things, so keep that in mind. So let's go ahead and just do one. We're going to call this x1 and this y1. We'll call this x2 and this y2, and go ahead and plug into the midpoint formula. But this is all it really is. I mean, midpoint is halfway, so let's just find the distance and take half of it. So halfway on the x is going to be x1 minus x2, so that would be -1 minus 4, all divided by 2. Just remember the numerator here is grouped. You need to do that first. That would be our x coordinate for it. And our y coordinate would be y1, which is 5, plus y2, which is -3. And again, numerator is grouped, and you're going to take halfway of that. So then you just kind of solve each of these separately and get your answer. So -1 minus 4 gives you -5 halves. Divide that by 2 if you want, or you can leave it as a fraction at this point because it just doesn't go evenly. If you want, you can divide it out. I'm okay if you put it as a fraction though. So that's your x coordinate, and over here, clean up your signs. It's just going to be 5 minus 3 is 2. 2 divided by 2 is 1. I guess I'll put the intermediate step. That gives you 2 on top, and you're going to divide it by 2. So then when you divide each of these by 2, you'll get, well, -5 halves is not divisible by 2, so I might as well leave it like that, and 2 divided by 2 is 1. So this here would be your midpoint. Or this would be the point that is halfway between these 2 points. So again, it's just formula work today, very similar to yesterday. Just plug into the formulas and solve. Your formulas are listed in the notes from yesterday, so go ahead and do that. And Adam is asking about number 7. So let's look at number 7. I think we have the book open. What page is this on? Okay, yeah, I just copied this from Nick. Okay, so number 7 gives you a coordinate plane. Let me see if I can get our paste. Bring up a coordinate plane here. Let me see if I can copy the problem down here. Just give me a second to look everything up here. So this is number 7. We have our points at 1, 2, 3. 1, 2, 3. Looks like that point. Looks like 1, 2, 3. Looks like that point. And we're up 1, 2, 3, 4. Looks like that point. All right. And then it actually has a triangle. Let me get the triangle in a different color here. That way I can see it a little better. That's not the tool I want that tool. So there's our triangle. I am going to go ahead and name my points so I can actually get the points. If you want to do it that way, you can, but it's asking for what? Perimeter? Yeah, it's asking for perimeter. The easier way to do this is probably just by counting it. But you can use your formula for it. So I want the perimeter of this shape. Right, you can do it by counting. Hey, you can see, again, you're going to be using your Pythagorean theorem, so a squared plus b squared equals c squared. You can see, I'll do red. You can see this triangle here. I'm going to do it over this way because all my lines are going to be on top of each other with that axis there. You can see that triangle there. And again, this is a 90-degree angle here. So you should be able to get this. You should note that that is actually an equivalent triangle to this here. So you know those two sides are actually equal. So you really only have to do one and you'll get both. And then this distance here you should know off the top of your head just by counting your blocks. So I know this distance here between these 2 points just because it's a horizontal line. So that is 1, 2, 3, 4, 5, 6. So I know this distance is 6. Between here and here is 6. That's not really a good spot for it. There. Get rid of the lines underneath it. So there you go. You got that. And then you can solve this one here. We'll give you this distance, which is, again, these triangles are equivalent triangles. They are congruent because they're the same sides. Side lengths are the same. And angles are the same as well. So over here, we're going to get your top distance, which is this distance here, which you could be using as this distance as well. It is the same if you want to use this triangle version of it. I just did it over here again because all the lines are going to be on top of each other due to the fact that it's on the axis here. But this distance here is a 3, and this distance here is a 4. So I am going to call A3 and B4, and C would be this distance here. Now keep in mind this here is the equivalent of C because it is the same triangle. So I really only have to do this once because I noticed that they are the same. However, if they are not the same, you'll have to do it a couple times. But over here we have 3, C we don't know, 3 squared plus 4 squared equals C squared. And you can solve using Pythagorean theorem. You probably, let's see, 3 squared is 9 plus 4 squared is 16 equals C squared. So the square root of that and the square root of that. 9 plus 16 is 25 C. So 5 equals C. So this distance is 5, which means this distance is 5. And this distance here we already know is 6 because, again, we counted the blocks. So our perimeter is equal to 5 plus 5 plus 6, which equals 16. And I don't know if it gives you units on that or not. It does not give you units on that, so it's 16 units, whatever those are. That's one way of handling that. You could have also used your formula. You could have actually decided what these points were called and plugged into our formula. We'll do that in green, I guess. It's the only other color we didn't use. So if I wanted to actually name this point, I'll do it on this side. Again, we're noting that each side is the same, so we really don't have to do this once. But let's look it out on this side here. We have this point here, which is going to be 0, 1, 2, 3. And this point here, which is going to be, oh, I'm sorry, this is 3, 0. X is first, 3, 0. And over here we have 0, 4. So our 2 points here are 0, 4, and 3, 0. And then you can plug those into your distance formula. Distance equals the square root of x1, y1, x2, y2. x1 is 3 minus 0 squared plus 0 minus 4 squared. And here you'll note you get your 3 squared and 4 squared coming out here. This is your 3 squared. And this is, well, this is technically negative 4 squared, but again, once you square it, it's going to get rid of that. So negative 4 squared and 4 squared are the same thing. But I guess we'll put it like that, and you'll note you get your 9 plus your 16, which is right there. We're taking the square root of these things. Equals your distance. So distance here is going to equal the square root of 25, and distance still equals 5. And then note that you have 2 of them, and add them to your perimeter. So a couple different approaches on how to do that. One using the distance formula, one using the Pythagorean theorem, which is really the same thing. It's just one is solved for the other, and one is designed for using points as opposed to distances already decided. So they really are the same formula, just looks a little different depending on your context. Any other questions about anything? But really, it's just plugging and chugging into formulas. So again, you have, oh, it's in your notes, so I don't have to write them again. If we have no more questions, you can always email me. Make sure you're working on your science. If something is marked missing in the gradebook for science, make sure you're getting it to me. It is best that you put things in the Dropbox on the classroom so I can find it easier. If you just email or share things with me, it gets lost in all the other emails that I receive, because the only way people talk to me these days is through email. So try your best to put it in the Dropbox the best you can. All right, appreciate everything you're doing. Keep up the good work. If you have any questions, send me an email. We're getting close to the end here, guys, so stay with it. Got a few more weeks, and I'll talk to you tomorrow. Bye.